Good morning, pre-algebra. This is our lecture and examples for lesson 7.3. We're going to be looking at adding linear expressions. So, what is a linear expression? A linear expression is simply an algebraic expression in which the variable is raised to the first power. In other words, we don't have an exponent. We'll be getting to those much later. The other thing to remember about a linear expression is it looks like this. It is just a sequence of algebraic problems, right, or expressions strung together with plus, and then we'll get to minus signs a little bit later, but with some sort of symbol. So it's going to look something like this. Now, how do we go about doing this? Well, here again, like we were working on yesterday, we just want to get rid of our parentheses. We want to get rid of as many of those addition signs as possible. Basically, we want to simplify this. And really, we covered this yesterday, but this is just some more practice with some longer algebraic expressions. These are also called linear because we write, it's a long line of different things to do, whether it's addition, subtraction, multiplication, division, which we're getting to. Right now we're sticking primarily with addition. So one way we can do this is we can start to look for like terms, and we can do, solve, in this case find the sum of the like terms. So here we have the like term of 3x and negative x. Remember, negative x is also negative 1x, and so that's why it's a like term. So we have 3x plus minus x, right? And that means that these are also like terms because they don't have a variable, so we can do that. So we have 2 plus 4. So if we solve this, right, let me get back to red. If we solve this, 3x plus negative x, that really is 3x minus x, which means that we have 2 x's, right, left. And down here, 2 plus 4 is, of course, 6. So our final answer, let's choose blue for that, is going to be 2x plus, because we have that plus sign there, 6. There is another way to think about this, and without being in class together, it's a little hard to have the tactile items to do that. But if we were to, let me continue to erase this. If we were to use tiles, algebraic tiles, we could also kind of figure this out. So we have in this expression, we have 3 x's, and we have 2 single numerals. Over here we have, I'm going to erase that, do that in a different color, we'll do that in green. We have our 2 little squares, right? Over here we have a negative x, so I'm going to draw that in red to indicate that it's negative, and then we have 4 more green individual ones that don't have a variable. So as we're looking at this, since these are all, the green ones are all positive, right? So we're just going to add them together. We have 1, 2, 3, 4, 5, 6. So that means we have 6 here. And here we have 3 positive x's. We're talking about these ones here now. And we have 1 negative x. So this negative x cancels that out, which leaves us with 2x. And that's the way we can do it using algebraic tiles. All right, so a couple more examples. So let's do this one first. We'll choose a color here. So looking for like terms. If we're not using our tiles, we're just looking for like terms. So we have negative 2x, and 8x. So negative 2x plus 8x. Really, we can write that as 8x minus 2x. Remember, we can swap those around when we're doing addition. So that leaves us with 6x. All right, and then we have our constants. We have 4 and 4. So we have 4, positive 4 there, and that's a negative 4 there. Well, that equals 0. Oops, that was not a 0. Let's try that again. That equals 0. So our final answer is 6x, because we had a 0 there, so we don't need to write anything about it. All right, over here, again, looking for like terms. So 4x, negative 4x and 5x. Again, I can swap that order. So 5x minus 4x. That's going to equal x. And then I have a negative 1 and a negative 3. So negative 1 plus negative 3 equals negative 4. So that means that my final answer is going to be x minus 4. Okay. I hope that made sense. So let's go on. We're going to do one more thing in this lesson. We're going to learn that linear expressions can be used to find the perimeter. So the perimeter is found by adding all the sides of a geometric shape together. So for this rectangle, it's going to be this side plus this side plus this side plus this side. Now, since it's a rectangle, we know that this side over here is also x, and this side up here is 1.62x. So that means that we can simply write it as we take this side here and we times it by 2. We take this side here and times it by 2 as well. So that's why I have P for perimeter equals 2 times the length and the width plus 2 times the width. So we would write this out as 2 times 1.62x plus 2x. We would do that multiplication. 2 times 1.62 is 3.24x plus 2x. And since these are like terms, they both have a variable of x, we're now going to add the 3.24 to the 2. So 3.24 plus 2 is going to be 5.24, and then we have our x for our final answer. So let's look at a couple more examples. Now, with a triangle, we can't use that formula of P equals 2 times length times width because it doesn't have 4 sides. Instead, we just have to add them all together. So for our triangle here, we're going to have 9x minus 4 plus 9x, I'm going to put a parenthesis there, minus 4 just so I can keep track of where I am, plus 2x plus 3. Okay, so now I'm going to look for like terms. 9x, 9x, 9x. It's all positive. 9x plus 9x plus 2x. So 9 plus 9 is 18, plus 2 is 20x. Okay. Now, let's look at our other terms here. These are also like terms because they don't have a variable. So we have a negative 4, a negative 4, and a positive 3. So negative 4 plus negative 4 is negative 8 plus 3, and that's going to equal negative 5. So we have 20x minus 5 as our final answer. And that would be centimeters because we were given centimeters there. Okay, so that's all we're doing. So let's erase that one and try this other triangle one just one more time. All right, so here we go. So here we can do the right times 2. So P equals 2 5x plus 1 plus 2 times 4x minus 1. Ran out of space. All right, so first we are going to do this little bit of multiplication into our parentheses so we can get rid of our parentheses. Remember, we're going to distribute that 2 into our parentheses. So that means that we have 10x plus 2. I'm going to put the parentheses up just to keep this together. 8x minus 2. Actually, we don't need those parentheses, but that's okay. I did run out of room though. Let me rewrite that so I have a little bit more room. All right, so we have 10x plus 2 plus 8x minus 2. So that's what we got. Again, different color again. 2 times 5x is 10x. 2 times 4x is 8x. So those are those. 2 times 1 is 2. 2 times negative 1 is negative 2. Now we can do some basic addition. Look for like terms, right? We're still seeing about merging all of our like terms together. So in this case, we have a 10x. That's a positive 10x. And we're adding it to positive 8x. So that's going to give us 18x. And then over here, we have a positive 2 and a negative 2. Oh, that's going to give us 0. Right? So that's going to, those cancel each out. So that means our final answer is 18x. All right, good luck. Email me, and I'm working on seeing if we can have a video chat for any additional questions. But email me if you have questions. Have a great day.